So you had before beginning the session. So this is myself, Sagar. So I'm basically an enterprise architect, and I primarily work for Hadoop and Spark technologies. So most of my experience are into the Spark domain, and so I'm with Edureka for almost 2 years now. I'll be involving in all the trainings of Edureka, and as also most of the big data and Hadoop trainings, right? And regarding Edureka, I think most of you will be already aware of. So we are one of the most global online training providers, and this is particularly going to discuss on Spark, and also we are going to discuss on why we require Spark. Okay. Okay. So meanwhile, let it open up. Yeah. So it has come. So when we take on a typical Hadoop's MapReduce functionality, okay, one of the important feature of Hadoop MapReduce is, so whenever you give a task, right? So let's consider you have some 5 tasks. I'm just discussing on a very familiar Hadoop's MapReduce, right? So let's discuss on Hadoop MapReduce code. So you look back at when you look back at an Hadoop MapReduce, right? So basically what happens is, let's say you started 5 mappers or 5 process. You can either call a 5 process or 5 tasks or a 5 mappers. Okay. Let's consider you started 5 tasks. Okay. So what happens in the case of an Hadoop MapReduce? So when you start 5 tasks, so let me make it 5 in a row. So there are 5 tasks has been started, but the problem what we are going to face is these intermediate outputs, right? Before the final output comes. The final output is basically we are going to combine all the process and we are going to produce some output, right? So even before the final output comes, so the problem where Hadoop MapReduce faces the intermediate outputs. So whatever the intermediate outputs is going to come, right? So let's take this is task 1, task 2, task 3, and task 4. So every single thing which is going to be part of it, all these intermediates outputs which is coming as part of each and every task gets returned to disk, and the next process whichever is going to start, right, and next task whatever the task you are going to start after that, okay, it's going to again going to read from the disk, right? And once all the task has been done, so once the entire process is over, the final output is returned to HDFS, means the Hadoop directory, right? A typical MapReduce functionality, right? So final output goes back to HDFS, right? So here comes a problem. So the question here is, it's understandable if you are writing the final output to HDFS, right? You need to write the final output to the disk system. That is fair enough. But if you keep on writing all the intermediate outputs and to the disk, and if you do all IO operations between the intermediate output of the task, so generally it is going to be affect the performance, right? The latency is going to be really high, and this is not suitable for real-time systems. A real-time system cannot afford this, right? When I say a real-time system, let's consider Twitter streaming, right? And Twitter is basically produces stream of data. Continuous streaming of data is going to come upon, right? When I say stream of data, one can really understand per minute how many Twitter messages is going to come, right? It's going to be stream of data. So it is really not going to be affordable for a real-time data to process a real-time data. Okay, you need a low latency, right? You cannot afford an high latency system, right? So this is Hadoop MapReduce, a typical batch-oriented system, an absolute batch-oriented system, which can really afford its own time. For instance, generating reports, right? Generating reports are not real-time system process, so they have their own time. They can take their own time and they can afford their own time. But real-time systems cannot afford this. So to overcome this particular functionality, so Spark came up with a smarter option. So all Spark does was, instead of writing all these intermediate output to disk, so what Spark suggesting was, let's start writing all these intermediate output to memory itself. So I am going to start writing all the intermediate output of all the tasks to memory itself. So typically this is going to improve my performance to a greater extent. Yes, there are a lot of questions to be answered. What about if my memory is not able to fill the data which is required to process? And also the questions is how the memory is going to be handle huge amount of data, and there are a lot of other questions to answer, which is well covered when you take the Spark course or Spark architecture, right? So when we discuss on that, you'll get a better understanding. But technically, this is what Spark does. So why Spark is? So Spark is basically, and it is actually a MapReduce process, but on top of MapReduce process, it is extending the MapReduce process. But the thing is that instead all the intermediate outputs return to the disk, which is probably happening in an Hadoop MapReduce process, it just smartly writes everything to the memory itself, means typically to the RAM itself, so which is basically improving the process to a very greater extent. Okay, so that's what we say is Spark as an in-memory computing system, where every single thing will be computed from memory itself, right? So in-memory computing system, right? As I said, the questions of what happens if my data is not sufficient in memory, etc. Right? So that's have a broader explanation or a broader discussion when you join the course, right? We'll be able to tell you how that happens, but trust me, it's having a very smarter way of handling all the things, right? So that's what basically happens, right? So because of this particular activity, so Spark basically I can put in two ways now. Spark now has grown to a very greater extent, so you can use for a real-time processing. Yes, this is a real-time processing because it's typically going to be absolutely 100 times faster than Hadoop because it's happening in memory, and a Spark can also do a faster batch, right? So we can now say a Spark can replace in both sectors. You can do a Spark in a batch-oriented system, also for a real-time system, right? So typically you can replace your MapReduce over it, right? Now comes, so we can go back and say now you can directly start replacing MapReduce because Spark is also suitable for batch oriented. It doesn't mean Spark is suited only for real-time systems. A Spark can do a faster batch. You can put in a very faster batch mechanism, right? So this is what happens when you use Spark, right? So the immediate question anybody can ask is, it's understandable, right? So Spark is in-memory computing system, which was going to be happening in this memory itself. So typically it's going to improve the performance to a very greater extent. And it also ends in faster batch. But the question is, if Hadoop is existing already, so if this is Hadoop, which is controlled by a very smarter mechanism called YARN, okay? So how Spark can be used effectively in this? So what's the best option Spark tells us or Yarn tells us? So Yarn as a system or Yarn as a data analysis process, which is a part of Hadoop, right? Yarn as a system which is part of Hadoop. Yarn is Hadoop, right? So this is sitting on, so this is Hadoop HDFS, right? Let's take an HDFS. So this is where my data resides. All my data resides, right? All the data, all the big data resides. So this is Yarn, and which is typically executes all the data analysis like your MapReduce process, right? Now a question comes, how can you come back and tell me, because I use MapReduce for a long period of time and all my data resides in HDFS. How can I use Spark now? Right. So this is a question basically to comes back, right? So how can I use Spark? So that's where the biggest breakthrough happens is Yarn can execute Spark along with MapReduce. So instead of executing a MapReduce job, so Yarn is having the capacity to execute both. So a Spark can be integrated with Hadoop directly. There is absolutely no concerns. One can directly execute MapReduce. One can also execute Spark because of this. A Yarn can execute both. A Yarn can execute MapReduce as well as a Spark jobs. All you have to define whether it's a Spark or MapReduce job, and Yarn is having the capacity to execute it. So when Yarn executes a MapReduce job, Yarn typically, so the data in HDFS is going to remain as it is, right? So the biggest question comes to the people mind, right? Where Spark comes, Spark is typically targeting the MapReduce sector, right? Where a MapReduce is, but so the one thing is going to remain as it is. The data factor for these guys, either it's MapReduce or Spark, is going to be always from HDFS, right? It's always going to be from HDFS. So you take a call whether you have to use either a Spark jobs or a MapReduce jobs, right? So this is the typical way of using, right? So another interesting debate what's happening is, right, Spark itself is coming up with its own cluster. It's up to you to use or not, which typically it's not suggestible. Spark itself is coming up with its own cluster. Yeah. So that's the beauty of Spark, right? So Yarn itself can do both MapReduce jobs as well as Spark jobs, right? So to an existing HDFS data with Yarn, you can start writing your Spark jobs and ask Yarn to execute the Spark jobs and itself. And one more important aspect of the discussion what we are having, there is no such thing like we need to execute a separate cluster and all. Nothing like that. And Yarn knows exactly what to do. So one never needs to write a separate code to say to Yarn you have to execute. Nothing like that. The moment you submit the job as a MapReduce, okay, if you submit a MapReduce job or a Spark job, Yarn is having the capacity to execute, in fact, both at the same time, right? So you always stick to Hadoop. You are inside the directory of Hadoop. The data comes from the Hadoop. The only aspect is the job, instead of a MapReduce, you can write a Spark job, which is an in-memory computing job, which is going to be extremely faster than a MapReduce job, right? So now we are going to see an example, right? We are going to see an example where a Spark job is going to use the data available inside the HDFS and going to start processing, right? So this is typically what Spark does, right? And as I said, the questions of what happens if the RAM is not if the data loaded into the RAM and the RAM is not able to have sufficient amount of data, etc. All those kind of things you will understand better when you join the course, right? Which we can't discuss in this 1 hour period of time. So let me open up. So in fact, I just want to show you one more thing, right? So let me show you one more thing even before that. So let me open up one more thing just to show you. Even if you want, see, whenever you try to download a Spark, right? So I'm just going to Apache website to download the Spark, right? So when you try to download the Spark, you can always see very clearly the Spark says I come for Hadoop versions pre-built. So you don't want to do anything special, right? You just download me and start working on. I am already aware of how to work with Hadoop big time. So you never ever need to worry of what I'm going to do, right? So let's open up a Spark cluster immediately and let's do an example of how to pull the data from the HDFS to the Spark cluster, right? So let me open up the Spark cluster and let me do that. So I'm just going to open up a Spark shell, which is typically how to say is an absolute Scala oriented, right? So this is basically a Scala oriented, and it happens completely in the aspect of Scala, right? Because Scala the only language for writing Spark jobs? Definitely not. Definitely not. You can use Java and Python, Piney, so no need to worry about that. In fact, I am going to show you one more example with Python too, right? So we'll see both Python as well as Scala, but Scala is preferred because it's a functional oriented language and one of the most widely used languages, right? So let me let's first open up the Spark shell. I see that you're using Spark 1.1. Yes, I just use Spark 1.2 in Hadoop 2.4. You can also download the latest version too. Anything is fine, right? So let's open up the Spark shell. So let's say bin/spark-shell -master local, because I'm just using a local cluster. So let's the Spark opens up. So when it opens up, just to tell you whether Spark has been built up in which language, right? You can immediately get an answer. So typically you should have a very good RAM. Okay, that one thing I'm pretty much putting forward, because you should have a very good RAM to use Spark, right? At least you should try this in an 8 gig RAM machine. Okay, so it's going to be very tough using Spark without these activities. Okay, so let's say let's comes up. So as I said, it eats up most of the memory, right? So it tries to get the most of the memory in the machine. So in fact, if you see, right, to just tell you what happened now, right, while starting up. So maybe I can open you, show you something. So this is what, right? So you can basically see the. So let me. You can basically see the Scala option coming up, because it has the Spark itself has been completely developed with Scala, right? So that's something. This Scala is a REPL shell. When I say REPL means, and one important thing everybody has to understand is Scala is a JVM based language. Okay, so REPL is something when you hit here 1+1, right? You get the output of 2 immediately. So that's what REPL is all about. One never needs to wait for the output. It just comes up there itself. So now let's make sure Hadoop is up and running. So let me make sure my Hadoop is running. So let me say, so let me go, let's see whether the name node is running, or I will start Hadoop. Okay, my Hadoop is not running. So let me start the Hadoop too. So let me go to Hadoop. So I'm just going to start the Hadoop now. So just so now what basically we are going to do is just load a file from Hadoop and just try to execute an operation, right? Just try to do a simple operation just to see how much effective Spark is going to be and how much faster Spark is going to be. Okay, just to see that. And next I'll also show you an example of how to do the Spark with Python too, in SciPython, and just to show you how easily the machine languages and all can be done with Spark, right? So let this load up. So meanwhile, when Hadoop starts up, let's go to the slide and see some of the activities. And the slide and the code, what we are going to discuss, will be available to you all. So I see some questions coming up again. So please email to email all of your to support@edureka.co to get all the activities, right? So you can see very clearly Spark is actually, to be precise, it supports, apart from the MapReduce functionality, a lot of other things like the machine libraries, the Spark SQL, which is something getting very famous with data frame and etc. And Spark streaming, definitely, it's a real-time oriented system, right? And data frames are the most highly effective APIs which has been used. It is basically coming from R. Okay, so whoever worked with R will have a better understanding. We'll definitely see an example of machine library, how the machine library basically works, right? And one of the most important aspect of using Spark is low latency, means it's going to be extremely faster. So let's see an example. I hope Hadoop starts up. Let's go back to VM, and yeah, so let's go back and see whether my Hadoop started up. Yeah, my Hadoop has come up. So basically, let's do something. I just don't know whether what files I have in my Hadoop directory. Okay, I have a README file. So what we'll do basically, let's load this file and let's try to do some activities like how many lines having letter A and how many lines having letter B, right? So let's load this. So let's go to the Spark shell again. So first thing, I'm just going to load this file. In Spark, we load the complete data set. We call those as RDD, resilient distributed data set. So let me load this file. So I'm just going to say whereof, let's give any name like something like a log file, something. Okay, fine. So let's say val of log file equal to slash readme.md. You don't need to say about Hadoop specifically because Spark knows Hadoop as we already told, right? Spark is tightly coupled with Hadoop. So no need to say the full directory of Hadoop. Just you have to say which file you want to load from Hadoop. This guy loads up. Okay, you don't need to worry about anything else. So once we said that, the next thing is we have to say to Spark to load this file. So let's say like Hadoop, which is having a context, Spark is also having a Spark context. So what I'm going to basically say is, I'm going to tell to Spark, you have to start working with this particular file. Okay, so Spark provides me a Spark context built-in object for that. So I never need to worry about that. So when you say to the Spark, get me the data. So SC is an object called as a Spark context, which is already available as part of the Spark cluster. So let's load this file. So now we are telling to Spark, okay, fine. Now Spark has loaded this data. So this log data is something called as an RDD, resilient distributed data set. In Spark, we call the data sets as RDD, resilient distributed data set. So typically what we did is we had a file called as a readme.md file in Hadoop, and we have loaded into Spark, which is called as a resilient distributed data set, right? So you can do any activities with this data set what we have loaded now. So what I'm basically going to do, I'm going to write some Scala code to basically count the number of lines which is having A, right? So Scala is a very brilliant code where you don't want to write like too much of code. So everything can be done in one shot. So let's say val of lines with A, right? So log data dot filter of. So I'm just basically going to say line of. So this is basically a complete Scala. When you join the course, you will really understand all this Scala code. So you don't need to worry about this now. Just a code I'm writing to count the number of lines it's having. Let's say A dot count. So let's see how much. So basically, we write a job to count the lines which is having A, and believe me or not, the job is done. It says the total number of lines is 60. So I'm pretty sure one that come from MapReduce can really understand how much fast it worked, right? It's just in a matter of 1.615 to 69 seconds. It loaded a file from Hadoop. It has done a job, and the job is to calculate the number of lines containing A, and it has executed, right? Even before we about to discuss of what happened, it says yes, lines with A is 60. In your file, there are totally 60 lines is having the letter A, right? Do you guys feel this is faster or not? Is this faster compared to MapReduce? Am I right, everybody? Particularly people who have seen MapReduce, right? You all agree? Right. So so that's the aspect of Spark, right? So that's what I'm trying to tell. So we just loaded a file from Hadoop, and because it's so tightly coupled with Hadoop, you just have to start Hadoop. Okay, you just don't need to do anything, right? So as simple as that. Right? We are not able to hear you. I don't think so, Deepak. I think everybody else is able to hear me properly. I'm pretty sure. Please, can you check from your side? And because nobody else is facing any trouble, so please check from your side. Yeah, fine. Thanks. So now I have just discussed, right? So some of the aspects. So this is what Spark. So basically that's what we say, right? Cuts down the read write IO to disk, right? So let's do something out of the box, right? This is something like a typical hello world kind of application. What can Spark can do a machine library, right? Means this is whatever we did is basically try to do an operation what you do with the typical MapReduce functionality, and we basically did with the Scala chart, right? So let's say I want to load some data. I want to have an histogram. Can Spark do it? Means let's just get some other functionality of Spark. We don't want to discuss the map. Yes, we discussed the MapReduce functionality to an extent. Can Spark do an IPython means is something matplotlib. So basically, I'll just show you what is a matplotlib, and I can come to that later. Just to tell you what are the other things Spark supports, right? So I'm just showing you something. What is matplotlib means? Just showing you all. So matplotlib is basically one of the most widely used library, a Python library, something kind of thing, which is effectively used across the globe for effectively all the histograms, etc., all those kind of things, right? Right. So let's see how to do this in Spark. I'm just going to show this example because we have to come out of MapReduce and also try to do an example of how Spark supports machine library too, right? So let's exit the system. So now I'm basically going to start. We are just going to explore an example now and how we basically can do a diagram, right? So what I'm basically going to do is, so let's say I'm just going to show you a data, right? So the data which I'm going to discuss is, let me show you the data from where I taken this data, right? So I have taken the data is from one of the famous websites called as Movie Lens. So Movie Lens is a website and which provides you a lot of data. If people are interested to work with data, you can go to this particular website, which has a complete data set about the users category, users age, and a lot of different sections regarding the movies, right? In that, I have just downloaded one of the data sets. So just show you one of the data set what I downloaded. So go data set. So let me open up the data set. So this is a complete data set which basically I have downloaded from that particular website, right? So in this, let's discuss, it's a huge amount of data. Okay, I have taken the huge amount of data just to, for this presentation, I want to show you how easily Spark can do an histogram for you, right? Just to analyze and how to do a machine library with Spark. So let's say let's open this particular data, user data, right? Always working with user data is going to be easier, right? So this is having a huge means it takes some time to open up because yeah, it opened up. So uh, how do I perform a Spark job from a Java code? We will have that example when you join the course, Pramod. Because it's a 1 hour session, I can't show all the examples. So, but when you join the session, when you join the course, we'll also show you how to do from Java code. Fine, Pramod? So basically in this particular data set, what we are basically trying to do is that let's find what is the total number of users, what is their genders, what is their occupations, and etc. All those kind of things. That's what I'm basically going to do from a very huge data set. And also let's draw a diagram. Let's historically draw a diagram for them. Okay. So I'm just going to show you the same thing to do with Python, right? Because we saw Scala now. So let me open up the Python shell. So we are going to use the matplotlib. This is basically a machine language kind of thing what we are going to do. So let's open up the IPython version. Okay, due to short time I can't do everything, so I'm just showing you how easily. Okay. Is it mandatory to use Scala? Nothing like that, but Scala is preferred. Scala is preferred language over the lot of things because Spark itself has been developed with Scala. That's the only thing, Deepak. Nothing. Okay. I will discuss about the course after this example, Prakash. I'll tell you what's there in the course. Okay. When MR is preferred over Spark, definitely not now Manas because we are basically doing a lot. We are basically doing a lot in Spark today. And people who is asking questions on Java, even I am from Java, one of the biggest thing all you have to understand is Scala is a JVM language. You can directly use Java code in Scala. So for an example, see, I'll just show you. So first you have to understand that very much clearly, right? So let's finish this example. I'll come back to that. I'll just come back to that. Okay. So let's load the user data first. First, let's load the user data. I'm just going to load the user data wherever available. I'm just loading from the local file system because I can't type the code. I'm just copy pasting the code from a file. So I just loaded the complete user data. So after loading the user data, I'm just trying to execute some of the
the Python code, which is basically trying to get the user fields and number of users, etc., all those kind of things, right? So I'll just execute everything. So first I'm getting the user fields. So from there, from the big data set what we have, I'm trying to get the total number of users. So next, let me get the num users. So let me execute this. And so see the fast it does, right? That's what Spark is all about. So I'm just next calculating what's the total number of genders. Okay, it's just a matter of seconds. It's just finishing off, right? So we calculate two things: number of users, number of genders. Let's calculate the number of occupations, right? I'm pretty sure in MapReduce you can't do this much fast. See the way it does, and that way this is in a VM. It's not in a cluster, right? And the total number of zip codes. So from a big data set file, we calculated four major things: the gender, the number of users, and the zip codes, etc. All those kind of thing. And finally, I'm going to print what is the total number of users and the etc. All those kind of thing. So let's paste it on. So it says the total number of users in your data set is 943. The genders are 2. The occupation is 21 and the zip code is 795. So from a very big data set, we just wrote 4 lines of code. That's the power of Python and Scala, whatever it is. Then Spark has executed a job and it's telling me now the users is 943, genders is 2, occupations 21. I never seen which is faster like this. This is fastest. I basically see this is the most fastest thing happens in the execution, right? So this is definitely the faster compared to anything else, right? So as simple as that, right? So let's say if I want to use an histogram kind of thing. So I want to just say, I want to draw an histogram of all the ages, okay? I want to do an histogram of all the ages. So let's do that too. So this is where Spark is very, very critical. Spark will support in both ways. Spark will support SQL, also it will support the machine library. So that's why it's so much important to work with Spark. So now all of a sudden, out of the blue, this guy is supporting something which we are not familiar with our MapReduce. So he's done an histogram for me. He's telling, so typically the histogram is now coming up. Yes, came up, and you can basically see age something around 28 to 30 or the highest, right? Or the highest ratio. Age around 28 to 30 rated something between 4 and 5, and they have the highest margin, highest ratio. So okay, so what we did basically, we did a Spark job and we used a matplotlib, which is Spark is not aware of. It is using that matplotlib and it came up with a graph all of a sudden. So we are able to execute the machine library in Spark. So that's the beauty of working with Spark, right? So I'm just executing. So I just taken the data set, I just executed some of the job, came on, and it's done. So that's the idea of working with Spark, right? So the question on Java, right? So let me, how long would the same program execute if you use a MapReduce job? Definitely it'll take at least some 2 to 3 minutes more. And drawing an histogram is not an easy job, right? Drawing an histogram, you should write an enormous amount of code, and Spark does everything in one line for us, right? So the question on Java and Scala, so one has to very clearly understand Scala is a JVM based language. Okay, is there any limitation of Spark? Nothing like that, Manas. Only one thing I see is the releases are extremely huge. So there are huge number of releases happening. So almost if you see, right, there's one thing I see where almost for every month one release is happening because of the language is used so widely. The features are so much it used extensively. That's the only thing. So if you see what I can do is you can directly say import java.util.date, and you can say var of a equal to new of date. So that is so please be aware that and you can say a, and if you print a, it prints the current date. Okay, so people who just think on Java, it's Scala is nothing major difference. If you know Java, you learn Scala just like that. Scala is just a JVM language. You can directly use whatever using. I just used my Java code here, right? I did nothing, right? I said import java.util.date, and I said, okay, if you want array list, you can say an array list also. It's a import java.util dot underscore. It imports everything, and you can directly go back and say new of array list. So there's nothing So you create another list. That's all. So if now Java Scala is nothing, so it's a user friendly. In fact, you can learn Scala very much fast. So it's just user friendly. Okay. How by drawing an histogram using R and shell, you can do that. So Spark is having very good support for R. Okay. Can you please compare data analytics with R and Scala? So Spark, if you have R, you can directly use R with Spark directly. Spark is having a very direct support for Scala. So okay, so don't need to worry about that. So R Spark is having a very good support for R. R with Spark is available, so you can directly use all the Spark libraries with R. Okay, and you can start working on in your R in your in your R console, either it is an R Studio. All you have to you do is just install the Spark libraries and start working with it. As simple as that. Okay. Can we use Spark jobs in Java instead of Scala? You can use Deepak. There is absolutely no restriction at all. You can definitely use, right? The thing is that Scala is preferred because Spark is developed with Scala, but apart from that, there's nothing else. You can definitely use. Okay. There's no such restriction at all. I have very less time, so I'm not able to do it. If once you moment you join the course, definitely you'll also see an example of Java. There is no such restriction, right? We use Scala as well as Python, right? So Spark SQL is typically basically coming with concept of 5. Again, due to time shortage, we are not able to do it. When you join the course, you will definitely look into an understanding of a data frame and the Spark SQL to a very great direction. It is basically making, you can put in this way, it makes Hive extremely faster. Okay, so the moment you join the course, you will basically get a complete understanding of what is Scala, how Scala, and we'll also go the Spark jobs. We'll also execute the Python jobs as well as the Hadoop jobs, and we'll also go in-depth analysis of how to use the Spark. So use of Spark SQL. So Spark SQL definitely going to Spark SQL is nothing but how and Hive works the same way Spark SQL works. The only thing is it is going to be extremely faster. It is going to be extremely faster compared to anything else, right? So that's the advantage of using Spark SQL. Fine, Nirav. Is Python needed to do the course? No, nothing like that. Sridhar. We just show you how to do with Python also. It's option is yours. Either you can use Java or Scala or Python. There's no such restriction as it is. Okay. So more about the course and the course details, you can always contact the support, and I will be part of the course. I'll be taking you all the Spark course. You can get more details about the course with the support team too. Fine, everybody. Any questions from you all? I will go on and share you all the details of the course and etc. You can come back. Okay. Can do all job in Spark SQL? Yes, you can do all the job in Spark SQL. There's no such restriction as it is you have Spark SQL. You can directly use Spark SQL. Yes, you can definitely. It's very easy, user friendly to use Spark SQL. Okay. There's no such restrictions at all. You can directly go back and use Spark SQL. Once you join the course, we'll give a very good understanding of that too, right? In which situations I use a MapReduce job versus using Spark? As I said, Murli, there is no such situation comparisons and all. You can directly go on and start using Spark by replacing your MapReduce. You can't compare MapReduce with Spark, right? Because Spark is extremely faster. It is like replacing MapReduce with Spark instead of comparison. The course is helpful for SQL developer. Yes, it is helpful. Can we say Spark will replace MapReduce? It is already replaced, Shajan. It is already replaced. I will say it is already replaced. So the concept of drive class to submit the job, etc. It is there, but that's why when you come to the Spark architecture, we'll go in very much in detail. When you join the course, we'll explain in depth of what's going on. So the major 5 reasons of Spark is in demand, as I said even in the beginning of the session, right? The major 5 reasons are, one is the latency, which is technically Spark is extremely faster for real-time processing, and it's having an extreme streaming support, machine learning and graph, which we have seen now, and data frame, which is coming as part of your Spark SQL, and it's having a very easy integration with that. That's the major reason.
Okay. However, the Cassandra is being used. Different application uses different aspect. If you use Hadoop, okay, Cassandra is something which is not coming as part of Hadoop. Right? We are talking on the community of the site which uses Hadoop, and definitely Hadoop used a lot. Hadoop extremely used a lot, right? So you can always go back and look back into that, right? So some of the aspect like is you can sort an 100 TB of data extremely faster if you use a Spark, right? So this is some of the benchmark which we already did. So this was a previous world record for 72 minutes. So Spark was able to come with 23 minutes, right? So definitely you can see how much faster it is, and basically, so there's a complete benchmark. Okay, what's the scope of Hadoop and Spark? Hadoop and Spark. Definitely, you can see a lot of scope, Pramod. The most widely used is Hadoop and Spark these days. You can see a lot of scope these days on Hadoop and Spark. Definitely, you can see it. Is Spark job same as MapReduce? No, it's not same as MapReduce. MapReduce does in disk, Spark does in memory. So it's technically not. Definitely not. Yeah, we will email all the slides and the programs which we discussed as part of it. Okay, we'll technically email all these things, etc. Okay. So this is the survey. So you can basically go back and look in the survey. So 31% are already using Spark and 20% are planning to use Spark. So we had a very nice survey, and we came up with a survey of how much Spark has been used in the market today. Okay. So all the slides and all the examples will be available to you. You can contact the support team, and regarding the course fees and etc., it is available everywhere, Deepak. It's an online course. You can join from your home. Okay, so you can contact the support team at the same time. So you will definitely, I'll ask the support team to contact you, Deepak, definitely on that. Okay. Yeah, so regarding that, Shahid, so that's what I'm trying to say, right? So once you join the course, we'll explain you in detail of what happens inside the Spark architecture, right? How it handles the data in the RAM. There is a lot of other things like Spark is having like spillover concept and all, which definitely handles the data, right? We'll explain you in detail when you join the course, right? On those aspects, the Spark architecture, everything. Yeah, yes, Deepak, you can obviously you can join the course. We'll give a very better picture. Yeah, you can definitely say future is Spark. You can. I can guarantee say yes, future is Spark. Yeah, so scope of freshers is always learning, knowing things on the big data is always good, right? Chandrakant, it's always good to be part of the big data environment, right? Knowing anything in big data is always a good point, right? Yes, Prakash, you can please go with your request. Yeah. No such minimum experience. Yes, Pramod. So it is that much silence actually. So it says there is no background disturbance at all. So medium experience, yes, there is nothing as such medium experience at all. You can join it. Okay. Anything knowing in big data is always a good aspect, no, Chandrakant. This certification is available for Spark. See, basically what happens, Manas, when you join this particular course, right, you will be provided a use case, and Edureka will provide your certification, right, which will really help you in getting it. And the actual certification of the Spark comes something called as Databricks. Is a company which founded Spark, and they have their own certification. But the Edureka certification will really help you a lot in moving your career aspect. So from there, you can go also, if required, you can also go and take the Databricks certification too. Okay. What is the fee? If you are, there is only one fee, Deepak. Okay. You can take this course only from your home. It's an online course, and you have a 24/7 support. I think you can always contact that support team on that aspect. Okay. Can you please give an email ID? I have just a few. Yeah, you can always contact the support, Prakash. So don't need to worry about that. I given the support email ID, right? So you can contact the support, right? I just give you an email ID. You can see the email ID. You can post any of your questions there. They will help you out. Okay. So Spark replaces Hadoop in near future. Definitely will replace Hadoop. Definitely. Okay. What is the timing for the next course? Again, the support will answer you better, Piney. You can also go to our website, right? You can also go back to the Edureka website. Maybe I can show the website. Okay, just a second. You can show the website too, so you can always go back and look get all the details regarding the Spark there. So this is the website. I'm just sharing the website, and you can. So it is Spark. Okay, if you go to the Spark here, so you can always go back and get all the details. So this is a place you have to go and get the details about the Spark. So you can go back here. So this is a particular location of the Spark. So you can find all the details, and you have a toll-free number if you are from US. You can see on the top. This is a support. You can always contact, and basically you can get all the details. Okay. Basically, one can get all the details about the Spark and etc. from this, right? So fine, everybody. So you can always go back, right? Okay, so I will make sure all the things what we discussed, the slides and the examples will be available to you all from the support team. And please post all your questions to the support. I hope this particular session gave you some good level of knowledge on what is Spark and etc. And please contact the support team for any contact, anything regarding the course. Go to the particular website which I posted. Also, you can contact the support team, 24/7 support, and please post all of your questions because it's a 1 hour session. I can't take all of your questions, and please be post all your questions to the support, and they'll make sure you will get back to answers. Okay, thank you very much, everybody, and hope we will see you soon in the any of the course. And please fill the feedback at the end of the session. And as I said, I cannot provide all the information due to time duration. Just I have to make sure an introduction to Spark and just to give a glimpse of what's going in the real world on Spark. Okay. Thank you all. Please contact the support and please fill the feedback. Thank you very much.